the number E. Now, the number E is just a number like pi is a number, 3.142, and I can find that value E using my calculator. So if I go to second function, e to the power x, this calculator works much better if it's on, e to the power x, and we say e equals 1, so e to the power 1, we get an answer of 2.718281828. This is an irrational number. It means it just carries on forever and ever, just like pi. Now, it is just a number. This number is on the number line, and it was always there. But about 400 years ago, this number has been discovered because of its very special property. Now, unlike numbers like pi and square root 2 and values like that, that has been found geometrically, this one has been found working with interest. Now, what happens is the following. Let's say that we have we invest $1 and we're going to get 100%. We're going to get 100% interest, which means that it's going to be 1 over 1, and I'm going to get that once a year. So if I get 100% interest, it means that after a year I'll get $2. If the bank decide that they're going to give me 50% interest, so that is 1 and 2, but they're going to give me twice a year, that will give me a value of $2.25. So for every dollar I'll have a total sum of $2.25. If I do that, let's say for every trimester, it will be 1 plus 1 over 3. And for every trimester, I'll get it 3 times. My answer will be 2.370. Let's say we do it 10 times a year. So 1 plus, I'm going to get 10% 10 times a year. The value becomes 2.593. And so I can go on. I can go up to 1 plus, and I can say it happens every second or 10,000 times. And what happens is this value becomes 2.71692. And the more I do it, the bigger I make this value, the closer and closer I'm going to get to Euler's number. So that E is called Euler's number, but it's just a normal number on the number line with very special properties. So the number E then is when I say 1 plus, and I say I'm going to go from 1 over n times, okay? But I'm going to limit this to never. So I'm going to say it's the limit. I'm not going to limit that. When n goes to infinity, then Euler number will appear. So this number, if you go on to infinity, it will get closer and closer and closer to 2.7182881, carrying on and on and on. So that is how Euler's number was originally located. What is so special about it? Why do we teach to you this in year 12? Well, in year 12, we're not going to do much, but this Euler's number has got a very special property. If I draw the graph of y equals e to the power x, right? Y equals e to the power x. Remember that in differentiation, we can find the gradient at any point. Now, if I find the gradient at any point for this function, it's the only value, so it means 2.718281 to the power of 1. If I go there, the gradient is always exactly the same. Not only that what we're going to do later with integration is we're going to find the area under the curve. And if I find the gradient, if I find the area of this graph from that point to infinity, that area also equals e to the power x. Doesn't matter where I go on this line. So if I go to another point, if I go to a point there, the gradient there will be the same as the value there, and that will be the same as the area that's under my graph. This opens a big field when we get to calculus, and calculus is differentiation and integration. And when we need to prove stuff, and I know I can use this value, it makes it much easier. So for future references, you need to know what E is. I'm talking about university level. We just need to teach you how to work with these values. So when we talk about the number E, it's going to be used for natural logarithms, called the natural number, natural logarithms. And all you need to know is that it is a value that's got very specific properties.